The video that follows aims to demonstrate how a good portion of the Oracle embedded software portfolio could be used in a vertical solution. In this case, we'll choose a simple medical application. Now, the components of this application are as follows. As we progress, we'll get into more details, but a first pass looks like this. First off, we have what you would call an aggregator device. That's not only appropriate in the medical arena, but in other verticals as well. And its job is simply to collect data from external sources. In this case, we have a USB-connected pulse oximeter. Patients would put their finger into this device. You'd get a pulse and an blood oxygen level content. It could have been any other medical device, and the transport mechanism could have been something other than USB. It could have just as soon been Bluetooth or Zigbee or Wi-Fi or a serial connection. This is what we have for the demo now. So once this data is collected, it's stored in a local database on the device and then sent upstream to our database server. Now, on our laptop, we have an Oracle 11G-R2 database, and in addition, we have another key component, the Oracle Database Mobile Server. Its job is to synchronize with various external devices the contents of that data in many different fashions. So what ultimately will happen here is we'll collect data from the pulse oximeter. It'll be stored locally on our data aggregator device. It'll be synchronized up with the Oracle database in this laptop, and then the Oracle Mobile Database Synchronization Server will furthermore synchronize up with a mobile device. So the idea here is if you're a doctor, a medical professional, and you're out in the field, and somebody out in the office has collected some patient information that might be useful for a doctor, they should be able to view that information from an application on this mobile device. With our introduction out of the way, let us first focus on our data aggregator device to give you a feel for what components in the Oracle embedded software portfolio are installed on this machine, and to show you how straightforward it is to get these components up and running for this demo. So the way we go about accessing our embedded device is via SSH. The device itself is equipped with an SSH server. So what you see here is a terminal window into that device. The IP address of it is 192.168.1.237. We've already installed Java SE Embedded here, and we can confirm that fact by just typing a Java-term version from the command line. And you'll see that it comes back with the version 1.6.0_30, and that it is a standard edition for embedded version. Now, standard edition for embedded means standard edition compatible, which means that we can take advantage of all of the SE compatible software that is out there in the world. Perhaps the most popular application ever written is the Apache Tomcat Web Application Container. We've taken the liberty of downloading that already. It is in our downloads directory. Oops. Here it is right here. And what we're going to do is install that now by simply extracting that data out. And that quickly, the Apache Tomcat web server is installed. And just as simply, to start it up, we issue a startup command, which is part of the distribution. And now we have a web container running on our device. With our web container installed, now we can access our data aggregator device to a standard web browser. We'll do that now at the address mentioned earlier, 192.168.1.237, and in this case at port 8080. What you see is the Apache Tomcat banner page show up. We can confirm that in fact we're running on our embedded device by taking a look at the OS architecture of it. You'll see here that it is ARM, not x86, and it's running that previously mentioned 1.6.0.30 version of JVM. Now, one of the nice things about Java EE and these web containers is it's really straightforward to deploy applications on them. We just went to the application page of the web container, and you'll see that by default Apache does install a few web applications already. What we want to do now is install 2 more, and that will get us up and running within the context of this demo. So the first of them is something called Pulse Gateway. So we're going to go ahead and find that WAR file. We're going to deploy it into the web container. And now you'll see that it is listed as one of the applications up and running on this device. The Pulse Gateway web container is responsible for number one, the plumbing. The pulse oximeter is hooked up via a serial USB connection. It will handle via Java doing that connection. Also, the Pulse Gateway program is responsible for reading that data and then putting it into a format suitable for other applications to digest. So it converts it into an XML string and is furthermore published onto a socket such that other applications can open that socket, read that data, and perhaps display that, as we'll show a little bit later on. The second application that we want to deploy and install on this web container is the database component of our demonstration for the data aggregator. So we'll go about the same process to install that. We will locate the WAR file, which is called healthdbsync.war, and we'll deploy it onto our web container. Now this takes a little bit longer to install, and the reason why is it includes a database sync client from the database mobile server, and the first thing it will do is pull down the database, our master database, from the Oracle server onto this device. We use Berkeley DB as our local database, a very fast, very capable, lightweight database. And you'll see now that, in fact, the Health DB Sync database synchronization application is up and running on our application server. Now that we have a local database deployed, we can take advantage of some of the servlets that come in the Health DB Sync web application to get a feel for what our database, our simple database, looks like. There are 3 tables in our database. The first is a patient table. What you see is we have each row has a last name and a first name, a unique patient ID associated with the patient, and then finally an ID associated with the doctor who's responsible for that patient. And you'll see here that there are multiple patients assigned to each doctor. We have a simple doctor table. Right now we have 3 doctors. Each one of them has its own unique ID, so you can go back to the previous patient table and get a feel for what patients are under the care of each of the doctors. And then finally, we have a pulse oximeter table. In this case, we're showing this joined with the patient, such that what you see here is a particular patient at a particular date and time got a reading with pulse and oximeter blood content. So here's a list of recent updates. What we'd like to do now is show how we can update this database by taking a reading from our pulse oximeter. Returning back to our data aggregator and medical device, let's go ahead now and take a live pulse oximeter reading. With that reading taking place, now we can start up a client which will read that aforementioned published data from the socket. So we'll go ahead and start that reading now. And you can see that we're collecting that data real time. What we'd like to do now is get a snapshot of this recording and store it in the database. So the first thing we'll do is we'll load the patients from the patient database. We'll select one, and now we'll record that information. So what you see here is that at 10:09 in the morning, the heart rate and saturation are 75/99 for Jim Connors. So now we can return back to our relational database locally on the device. We'll refresh the screen, and you should see now that in fact Jim Connors' pulse oximeter reading has been entered into the database. So what we'd like to do now is demonstrate how the database can be synchronized on a mobile device. The Oracle Database Mobile Server has synchronization clients for many platforms, Android being one of them. So we've gone ahead and created an Android application, which we'll go ahead and start up now. And the first thing we'll do here is move over to our pulse oximeter tab. Now, we performed a synchronization in the past, so there is some data on this file, on this device already. So let's go ahead and open up the database, and we'll select Jim Connors patient, and you'll notice that there are 4 records, and we can scroll through each one of the pulse oximeter readings. But what's missing here is the most recent reading we just did, and the reason why is we haven't performed the synchronization on this device. Now, when developing these type applications, you more than likely are going to do it in an automatic and transparent fashion, which is highly recommended. But for the sake of this demonstration, we want to do a manual synchronization to show that the synchronization process does take place. So let's go ahead and close this database up. We're going to return back to our synchronization tab. And what we're going to do here is log on to the mobile database mobile server with user M. Welby. M. Welby matches the previous screen that we showed of the doctor lists to Marcus Welby, Marcus Welby MD. For those of you who know who that is, you're showing your age. So let's go ahead and log on as this guy and synchronize with the database and see what happens. So synchronization takes place. We'll return back to our PulseOx tab. We'll reopen the database. We'll select Jim Connors again. And you'll notice this time that there are 5 database records. The most recent being the one pulse oximeter reading that we just took. So there you have it. In conclusion, what we've shown is how certain aspects of the Oracle embedded software portfolio could be utilized in an application, a medical application. In this case, we showed that Java runs on embedded devices and is standard edition compliant, such that off-the-shelf Java applications could be utilized to deploy and manage applications in a seamless manner. After that, we demonstrated how a local database on the device could be used and synchronized with Oracle 11g R2 database and the database mobile server program, such that a mobile device like an Android phone could synchronize with that database and receive data as changes to the database take place. Now, the Oracle Database Mobile Server package is a lot more robust than we demonstrated here. It has many more features, including the ability to do things like subset data onto the device and to actually manage those devices. But that is left to another day. This concludes our presentation.